Okay, so when you're asked to use the multiplicative property of equality with fractions, you may see a problem similar to this one or this one. You have to go back and remember what your job is in solving a fraction, an equation. Your job to solve an equation is to get the variable by itself, okay? So my job here is to get the variable by itself. So you need to focus on the variable. So Alex teaches you guys to use reciprocals, which is fine. I'm going to show you a different method here in just a second. A reciprocal is just whenever you take a fraction and you put the numerator on the denominator, denominator on the numerator. Reciprocals are numbers that whenever you multiply them together, you get 1. Okay, so what do I mean by that? So if I had 2/5, his reciprocal is 5/2. So notice the numerator went to the denominator went to the numerator. And it's because when I multiply those, I get 10/10, which is 1. That's the definition of a reciprocal. Reciprocal are two numbers multiplied together whose product is equal to 1. Okay? So it's just a flipping, I guess you could say, of those fractions. And those are called reciprocals. Well, if my job is to get the W by itself, notice that there is a fraction right here. And so Alex is telling you, you have to eliminate this fraction. It's called a numerical coefficient. So if you look at the number in front of the variable here, you notice that the number is a fraction, okay? It's called a numerical coefficient, and it's fractions. Over here, is the numerical coefficient a fraction? No, it's just a regular number. So my numerical coefficient here is just a regular number. So most of you guys are like going to the fraction and trying to use that fraction just because it talked about fractions. But what you're really trying to do is remove the numerical coefficient. So Alex says if the numerical coefficient is a fraction, you can multiply both sides of the equation by the reciprocal of that fraction. And now when you multiply, you get 20/20, which is 1. So that would leave you 1W. And then over here, you multiply 20 times 5 over 4. And 100 divided by 4 is 20. So the solution to this equation is 20. Over here, you don't mess with the 14/5 because it is not the numerical coefficient of the variable. So the coefficient of the variable is 2, which we could call him 2/1 to make him into a fraction. And now we have a fraction in front of the variable, and we can use the reciprocal. And the reciprocal of 2/1 is 1/2. So we would multiply both sides by 1/2. And so then that would give me 2/2, and 2/2 is 1. I get 1U, and this would be 14 over 2 times 5, and 2 times 5 is 10, and 1U is U. And then I have to simplify. Remember, we always have to simplify our fractions. I can divide by 2. So 14 divided by 2 is 7, and 10 divided by 2 is 5. So here is the solution to the second equation. Okay, does that clear up what your object is to get the variable by itself? Is that a little better?
Are you there?
I'm here.
Oh, yes, I'm here. Okay. It was breaking up or something.
Okay. Okay, so instead of using this method, which this is how Alex shows you to solve these, I want us to use a different method, which Alex is going to teach you later. They're just wanting you to understand reciprocals and how they work. But we can do all of our fraction equation problems a different way. So I'm going to say this is solving an equation with a fraction. And I don't care where the fraction is, okay? I'll do a couple different ones. So I'm going to take this first one, 4/5 or 4w over 5 is equal to 20. And I'm going to solve it a different way, okay? In the way that I solve it, you do have to find a common denominator. So finding a common denominator, for some people it's hard. It's not that hard. You just have to find a number that your denominators will go into. In this case, it's super easy because the only denominator I have is 5. So that means my common denominator is 5. Now my method's going to take you maybe one more step in a problem like this, but later in the other problems where there's fractions throughout, it really won't. It'll be the same amount of work. So what I'm going to do is, since I know my common denominator should be 5, since that's the only denominator I see, I'm going to multiply this equation by 5. So this is just like the distributive property. This is saying 5 times something. I'm going to have to distribute it out. And in this case, I'm going to multiply 5 times 4w over 5, and then 5 times 20. So I write it out, 5 times 4w over 5 equals 5 times 20. So now what I've done, notice I have a 5 and then I have a divide by 5. This is a multiply by 5 and a divide by 5. Those guys cancel each other out. So that's going to leave me 4w is equal to 5 times 20, which is 100. And so now I know to solve this equation, this is multiply. To undo multiply, I divide. So divide both sides by 4. And w is equal to 100 divided by 4, which is 20. So I do have an extra step in there, but I have eliminated that whole confusing part about reciprocals. So I just multiplied times 5. Okay, let's look at another one like that. Suppose I had 5v is equal to 10 over 9. Okay, so the only denominator that I see in this problem is 9, so that tells me my common denominator is 9. So I would multiply this equation by 9, so I'll multiply 9 times 5v and 9 times 10 over 9. So I'll rewrite that, 9 times 5v equals 9 times 10 over 9. So you can see that I have a multiply. Remember, a number next to a parentheses means multiply. I have a multiply by a 9, and I have a divide. A fraction bar means divide. So that means those divide out. And so 9 times 5 is 45. So I get 45v is equal to 10 because those 9s canceled out. And so now to get this v by himself, this is multiply. I divide by 45. And so I get v is equal to 10 over 45. But then I know that this can be simplified. Okay, I can simplify it because I know that these are both divisible by 5. So 10 divided by 5 is 2, and 45 divided by 5 is 9. So the answer is 2 over 9. Okay, suppose I had x plus 5 over 4 is equal to 3 over 4x. So this one's still kind of easy, but notice I have 2 fractions in this problem, okay? But it's not that difficult because my denominators are the same. So my common denominator for this problem is going to be 4 because my denominators are both 4. So that makes it easy. So then I would take this entire equation and I would multiply it times 4. So this is like the distributive property. I'll multiply 4 times this x, 4 times the 5 over 4, and 4 times the 3 over 4x. I write that out, okay? So 4 times the x plus 4 times the 5 over 4 equals 4 times the 3 over 4x.
Right.
Okay, y'all with me?
Yes.
Okay, so what's going to happen with this multiply times 4 and divide by 4?
Hold on. It's going to equal out.
Yeah.
Whatever.
They're going to divide out.
Exactly.
Yeah. And then what's going to happen with these?
Also the same.
Yes, they're going to divide out. So those like disappear, right? They're gone. So I get 4x, that's right here, plus whatever's left, which is 5, equals whatever's left, which is 3x.
3x. Okay.
Okay, so now I can solve. What do you think I should do next?
We got to just have 1x.
That's right. So tell me what to move.
So we're going to, I think we should divide 4 over 4 and 3 over 4.
Not yet.
No.
So our next step is what we call moving. Okay. So there are 1, 2, 3 terms in this equation. These are called terms. So my job is to get all the terms that have x's in them on one side of this line or one side of this equation, and the terms that don't have x's on the other side. In order to move terms, that requires an addition or a subtraction. We don't do any division, not until the end. So we have to add or subtract to get these terms to move from side to side. So my suggestion would be, since this x is already over here by himself, my suggestion would be to get this 4x to jump the fence and get over here. Okay? So I can't just stick a 4x over there. That would be illegal. He is a positive 4x, and so to get him to get over to the other side, I have to use his inverse. His inverse would be to subtract. So I subtract 4x from both sides. And so now I get a 0 right there. And so I have 5 is equal to 3x minus 4x. This is money now. I got money right here. So I have $3 in my wallet, but I'm supposed to spend 4. So I'm short 1. Okay, so that's negative 1x. Okay, so now that everybody's been moved, I've moved terms. I've jumped the fence with my terms. Okay, that's moving. That's adding and subtracting. Now my last step is to get rid of this numerical coefficient. This is multiply, so I use divide. So that divides out, so I get x is equal to 5 divided by negative 1. So that's a positive divided by negative, which is a negative. And 5 divided by 1 is 5. So the answer to this one is x is equal to negative 5.
Negative 5. Okay.
Okay, so let's solve x over 2 minus 1 is equal to 2/3 x minus 3. Okay, so now on this one, if you notice, we've got 4 terms to start with. So right away, you can be telling yourself, okay, once I get rid of the denominator, I call that, it's actually called clearing the fraction. What you've been doing or what we've been doing, clearing the fraction. We're clearing out the fractions. We're using the LCD to do that, okay? Once we get these denominators to cancel out like we did a few minutes ago, then we're going to have 4 terms, 1, 2, 3, 4, and here's our fence, and we're going to have to start moving them, all right? And remember, to move them, we use adding and subtracting, move them from side to side. We need the x's on the same side. I can't just write it over here, and we need the numbers on the other side, and I can't just write it over there. I have to undo it, okay? So let's go back to what our job is right now, though. Our job is to get rid of these fractions. So we have to get the LCD. So our denominators are 2 and 3. We're looking for a number that 2 and 3 can both fit into. What number is that?
6.
6. So I'm going to take this equation and I'm going to multiply it times 6. So I'm going to multiply 6 times this guy, 6 times that guy, 6 times this guy, 6 times this guy. Got 4 terms. I multiply by 6 4 times. So I'll write it out. Okay, so notice I just put my minus right there. It doesn't matter where you put your minus. I just put it right there, and I put the 6 in the 1, 6 times 1. And then I just stuck that minus right there, and I put the 6 times 3 right there. That's fine, okay? You could have written it differently, but I like to do it like this. I put my sign in the front, okay? So now this one's not as nice as the other ones, because on the last 2 problems that we did, we were so lucky because the LCD was the number, right? The denominator. And so then what happened? They just canceled out, right? But on this one, we don't have 6's down here. So what do you think is going to happen?
I don't have 6's down there, so
Does 2 go into 6?
yes.
Does 3 go into 6?
Yes.
Yeah, so what's going to end up happening is we're going to say the 2 will go into 6, but instead of it just wiping out, I have a leftover. Because how many times does 2 go into 6?
3 times.
3 times. How many times will 3 go into 6?
2 times.
Yeah, so see, I'm going to have a leftover right there. Okay? Now, what happened with these denominators? They disappeared. They canceled out. The leftovers are left up here at the top. But these denominators are gone. Okay? Because we divided them into that 6, and these are our leftovers.
So that 6 is gone also.
The 6 is gone. I only have the leftover. And this 6 is gone. I only have the leftover.
Okay, got it.
Okay, so now we multiply. 3 times x is 3x minus 6 times 1 is 6 equals 2 times 2 is 4x. So I did 2 times 2 right there. And then minus 6 times 3 is 18.
It froze. I'm sorry.
Okay, 6 times 3 is 18.
Okay, good. Okay.
Okay, so here's my fence. Okay, so there's my fence still. So I need the X's to be on the same side of the yard and the numbers to be on the other side of the yard. So I can move anybody first. It doesn't matter. I can move the 18 first. I can move the 6 first. I can move the 4x first. I can move the 3x first. It doesn't matter. When I work my problems, I always move the variables first, one of these, and then I always move the smallest one. That's just my habit, and that's just the way I do it. You don't have to do it like that. You can move anybody. But I pick the variables, and then I choose the smallest one. Okay, so since this is positive, to move him, I have to do his inverse, which is subtract him. So I will subtract the 3x from both sides. So this says 3x minus 3x, which makes a 0.
0.
And so all I have left on this side now is negative 6.
Negative 6.
And then this is just regular subtraction, 4 minus 3. And 4 minus 3 is 1. So that's going to leave me 1x right there. And then I didn't mess with this 18, so I just write minus 18.
Minus 18.
Okay, so remember, my job is what? What's my job? Get the x by itself. So
yes, it is.
This is like having a kid living in your house and crowding you. You know, this side of the fence is your house. You want him out. So you got to move him over. So to move him over, I will add 18 to both sides. And that makes a 0. So 1x is just x. I don't have to write the 1. And now this is money. You have $18 in your wallet. You went out and spent 6. You have $12 left. And that's your answer. X is equal to 12.
Okay, because I owe